Hello there, this is Daniele from Toolshelves and welcome to this new video. So today we're going to have a look at avoidances, more specifically to mesh and agent avoidances, and how we can combine them together with a context steering module. Then also we're gonna see how we can fix our avoidance scenes in post. And at the end of the video, we're going to see also how we can make an avoidance, kind of an avoidance manually, so by driving manually the crowds. So before we start, a couple of things. So whenever you want to use the agent avoidance and mesh avoidances and so on, it's always best to have a locomotion system in place. So a locomotion system is a graph that based on a couple of parameters, so a linear velocity which tells each agent how fast they should move, and also an angular velocity which tells the agent how much they are turning. Then Atoms with these two inputs is able to find some clips and blend them together. So for instance, in this case, whenever we are saying that the linear velocity is going to be 130, that means that the agent is actually walking, okay? If we provide a value between this node and this node here, then it will blend the man walk and man jog. Okay, so with the standard man that we ship with Atoms, we already provide a locomotion. We also provide locomotions for the characters that you can find in the agents bundle, so in the Atoms agents. So you can use those if you want. But just for this example, we're going to use the man from the Atoms from the agents. Sorry, from Atoms. So here, what we're going to do is we're going to create a grid layout. Then a locomotion module, and finally we're gonna add an add metadata module. So with the add metadata, with the grid layout, we're going to create maybe a 6x6 grid with a spacing of 200 by 200. We can maybe randomize a bit the direction, so we can do 0.2 and 0.2. Randomize the space as well. Maybe you can do 10 and 10, like so. Then we can apply a locomotion. So this one is the locomotion that I just showed you in the Atoms UI. Here I'm gonna enable and change, some parameters here. So first of all, I'm gonna disable the force unsynced clips. This option here, which is quite useful in some cases, it's taking care of a particular situation. So whenever there's a dramatic change in direction from one frame to another, let's say 90 degrees or 180 degrees and so on, then Atoms can play unsynced clips that are shown in your locomotion system with the squared icons as opposed as the circles. But if this option is off, we're never gonna select these the unsynced clips from a locomotion. Just in this case, I'm not particularly interested in using them, but if you want to use them, that's how basically you have to keep this enabled. Also, I want to change this value to the linear average non-frame and angular average non-frame to 10. And this value is used by Atoms for blending the inputs that we provide at every frame. So for instance, the linear velocity that we provide at every frame with in this case 10 previous values that we provide. So with the higher this value is, the smoother the transition of of these two inputs is gonna be. So you're gonna see less pops in your animation. On the other hand, you have to be careful with these values, because the higher they're gonna be, the slower your agent is gonna be to react to changes in the linear and angular velocity. So again, you might see agents maybe intersecting with each other, or maybe intersecting with a mesh. And this might be because, again, the value of these linear and angular average frames is too high. So in those cases, using a lower value is going to help. Okay, so this is done. Then what we want to do is we want to set a target linear velocity, which is the metadata that Atoms uses for driving the velocity that tells each agent how fast they should travel. Let's change this to skin. So as I showed you before, 130 was the value for the walk. So now if I press play, the agents are just walking. Great. So we might see some agents intersecting, like these guys here and these guys there. So to avoid that, we can add an agent avoidance module. Sorry, agent avoidance module. And we can go in here, agent avoidance. First of all, let me disable here the locomotion angular velocity here and set the linear velocity maximum to 130. With this value, this one basically we're saying we're not affecting we don't want to affect the metadata that is driving the angular velocity for each agent. And then with this value, we're saying that the agent should never go faster than 130 for the unit for the linear velocity. With this, we just say that we just want the agents to walk or be in idle state and blend between these two. And not use the jog, so we're never gonna go above 130. Then the other one, the other parameters that are kind of useful to use are the time to horizon. This one is a value that tells each agent how far in the future they should look for intersections. If you have a very packed area, with a lot of agents, you might want to decrease this value to maybe 1. Or a value that is lower than 2, and this will make the animation a bit smoother because of course the agents are seeing less intersections, they're seeing less danger in front of them, so they're not taking very sharp turns. And then we have the neighborhood. So if I enable here the debug, just quickly, so if I go to the next frame, we see all these lines here. These lines are basically telling you each agent how many other agents has found to avoid. Because if you remember correctly, here in the grid layout we use 200, and here the what is it, the agent avoidance, the distance neighbor now is 400. The agents are finding quite a lot of agents to avoid, but if we change this value to maybe 300, you see we have less lines already. We could even say 200, and there will be far less agents, but anyway, let's just stick maybe to 300. So now press play. We see that the agents are avoiding each other. Also, another thing that we haven't done yet, but we're gonna do straight away, is to decrease the max turn angle. With a very high value, you're making sure that the method, the algorithm, which is at the moment RVO, is actually driving the agents, and you're getting the exact output of RVO. If you set like a lower value, you won't get exactly what RVO is telling to each agent, but you won't see very sharp turn between frames, which again is great. If you have a low value, you can use a lower value for when you don't have a very packed area and you see turns that are not very sharp. But if you have like a very packed area, you want to increase this value. If you have still intersections, we can fix this in post, as we're gonna do later. So this is done. So if I press play just quickly, we can see that the agents are avoiding each other, and they're going, they're going pretty much in the direction that they had when they were created. Now we're going to select this agent group, and from the shelf, we're gonna click on the duplicate button. Always use the duplicate button from the shelf, because it takes care of also setting up the DOP, which is something that otherwise you have to do manually if you just duplicate the agent group. So we have, so this one was so this one is the agent group that we just created. We're gonna move it up here, and then we want to change the initial direction to -1, so they face the other direction. If I press play, now the agents are avoiding the agents from the same agent group, but not the agents from the other agent group. To fix that, we can go in the agent avoidance, go in the neighborhood tab, press plus here, and here we can add more agent groups to avoid. So here we want to select the other agent group, so in this case would be the agent group here without the 1 at the end. And then we have to do the same for the other agent group. So agent avoidance neighborhood, press plus, and then agent group 1. So let's go up. If we press play, the agents should now avoid each other. You can see some of them are getting confused, where they should go, and they actually, let me add some more frames. Say maybe 500. Yeah, 500 is a bit too much probably, but it's okay, just for this example. And you see now basically the agents anyway, they're avoiding each other. There's no intersection. Some of them are getting confused a little bit, but it's okay. I mean, at least we don't have an intersection. We can see still some of them are having like some sharp turns. We could go in here and maybe change the max turn angle to 1, maybe even change the time to horizon if you wanted. I just want to show you what happens when you set the max turn angle to a very low value. So 1 and 1, let's go up. So now, because the max turn angle is so small, we're gonna see intersections, actually quite a few of them. And this is also a scenario that you're gonna see whenever you have, you know, a lot of agents just playing one single clip, or a state machine playing just one state. So there could be cases where you have agents intersecting. You're happy with the rest of the simulation. You just want to maybe, you know, like edit those agents or remove them. We have a tool that is called Agent Deleter. So we can go under Atoms. First of all, we need to cache this simulation. So we're gonna select these two agent groups, and then we're gonna export them. So we're gonna export it there, let's say 500, and we want to, after export, import an agent group and create a cache reader. So now the simulation is caching. That's done. And now what we have here, if we go back, so the first two agent groups are now hidden. We have another agent group, and this agent group here is a cache reader, which is reading the cache that we just exported. I just change the display type to skin. If I press play now, the simulation is exactly the same that we had before. Now we can use a tool that is called the Agent Deleter, and we can select an agent group. So in this case would be the last one that we have created. Provide a frame range, so it could either be the current frame or a frame range that we can provide, or the entire frame range of the UI. Provide a radius, like we could say 80, and basically this is saying that whenever two agents are getting closer than 80 units, then you should delete that agent, one of the two agents, sorry. So I'm gonna click run. This is running the simulation, finding the intersections, and this will clean anyway all the agents that are intersecting for us. So that's done, and you see quite a few agents disappear now. These anyway, this process has just deleted quite a few agents, but anyway, you can even go there and you know, decide which agents you want to filter by hand. And anyway, we clearly use some parameters that weren't correct before by changing the max turn angle. But this is again a way how you can fix your avoidance scenes in post, especially if you use just one clip to drive your agent animation. Okay, so now let's create a mesh avoidance example. In this scene here, I've created a simple setup, you know, some tubes, a curve and a ground. I'm gonna create an agent group, and on this agent group, we're gonna create once again a grid layout with animation. There's gonna be a locomotion. We can have also a metadata for the initial velocity. And anyway, let's start like that for now. So we're gonna say I want maybe 8 by 8, maybe 200 and 200 like this. Some spacing. We can say, no, sorry, spacing already did it. So maybe random spacing, and once again the random direction at the beginning could be 0.2, 0.2. They need to face the other direction, of course. Locomotion, manned locomotion. Here again, I want to say 10 and 10. Let's again, once again, disable the unsync clips. Let's set the initial linear velocity to 130, like so, and change the draw type to skin. So anyway, that was a lot of steps, but anyway, this is what we have now. Agents not avoiding each other or avoiding the mesh. So we're gonna fix that straight away. So first of all, for the meshes, we can go under direction and find the mesh avoidance module. In the mesh avoidance module, you can do two things. So for the mesh avoidance, you can either use an height field, an Atom's height field, or you can use directly a mesh. If you want to use a mesh, which is totally fine, you can select the obstacle like that, That's the right one, yeah. Okay, so and now if I press play, the agents are actually avoiding the first cylinder, the first tube. For the other one, let me create a I field. So I combine these two under the same geonode. So if I go in here, let's add a new one. So let's call it avoidance. And let me select, where is it? No, this is not this one. Obstacle 2, select, okay. Then if we go on the mesh avoidance, we have to create, of course, another one. And here we can select avoidance. And once again, if I just, sorry, this is the name of the I field, of course. So if I press play, they should both avoid the first and the other obstacles as well, but they're intersecting with each other. Okay, so to make sure that they avoid each other, we can attach an agent avoidance. And in the agent avoidance, once again, let's make the max turn angle a bit smaller. Let's create the neighborhood to be, I said the neighborhood maybe even to be 200. Locomotion, we're gonna do the same things that we did for the previous example, okay? So that's okay, time to collision, yeah. Okay, so if we press play now, the agents should avoid each other. Actually, let me first of all enable that so we can see everything. But some of them are gonna go into the cylinders and the tubes. And this is because what's happening here is that these modules that we have attached to the agent group are kind of fighting against each other. Because Atoms, what it does is basically it's evaluating the modules following this stack. So first gonna create the agents, apply the locomotion, setting the linear velocity, working with the first two mesh avoidances and then the agent avoidance. All of like the directional modules, what they do, they set the new direction for the agents, but each module is getting the direction from the previous module. And in this way, they're gonna overwrite each other. In order to prevent that, what we can do is we can create attach a context steering module. The context steering module, what it does basically is instructing Atoms to fill some maps, so the interest map, the danger map, and so on, for the context steering module every time that we find a directional module. So in this case, it's going to be these two mesh avoidances and the agent avoidance. And then based on these maps, the context steering is going to find the best solution to make them, like to decide basically the right path. One other thing that we want to do is we want to give these agents a direction. So we want them to go towards this curve, because if you don't do that, you'll see that the agents are actually not if you don't do that, basically the result that you're going to get from the simulation is not going to be as good, because the agents will be kind of confused where to go and so on. So I'm going to put the follow curve up here. It doesn't really matter as long as it is above the context steering. The context steering module should be always the last module in the stack. So in the follow curve, we're gonna pick the curve, which is gonna be that guy over there. So now the agents are actually gonna go towards that curve. Let's change the max turn angle to 5 maybe. And if we press play, let's go up here. Now the agents are kind of avoiding each other. Some of them are still, going through a bit the meshes, and this is because again the even context steering is not able to find the best solution. What you can do, of course, if you can't find, if you can't manage to fiddle with the parameters and get the result that you want, you can still either move the agents at the beginning at the layout position or delete them, as we did in the previous example. But we can fix that by changing a couple of things. So first of all, we want to make sure to give plenty of time for the agents to avoid these cylinders. So at the moment we're just saying the distance is 200, which is, I think, similar to the neighborhood. Actually, yeah, it's exactly the same. So this one is actually the distance between the agents, while also we're using 200 for the meshes. What we want to do here is maybe we can say 400, like this, 400 and 400 here, and maybe this one is gonna look a bit better. Let's see. Yeah, so they have more space, more time to avoid the cylinders. Also, we could change a little bit the probably the sight angle should be okay, but maybe we can just increase it just a bit just to see, because this is actually, you know, actually this is not going to make any difference. This is actually the angle that the agents are using for finding intersections with the mesh. But yeah, anyway, the obstacles are exactly in front of them, so this shouldn't really change much. Yeah, actually that's what happened. What we can do is we can set a higher max turn angle here on the mesh avoidance compared to what we have on the agent avoidance, because these values are still used by these modules for clamping the final direction. Okay, so maybe actually, you know what, in the mesh avoidance we can say 8 and 8, and if we do play now, let's see if this changes anything. There's still this guy over there. There's one guy that is, I think it's this one. No, it's that one. It's the guy before that one that is going through. So what we could do is we could agent selection tool. We could enable the agent selection tool. So it's this guy over here that we don't like. We can go back and we can move it a little bit, maybe to the left like this. What this does is creates on the agent group a new module, an offset module, which contains the offset for this agent. So let's see if this actually made any difference. Maybe it did, maybe it didn't. No, it's still kind of the same. But what we could do instead then is that we could go back to the agent layout tool. Sorry, let me activate it first. So if I, no, it's there. Could move it on the back over here. Okay, so let's go back. Yeah, now it's much better. Anyway, again, you could have deleted that guy. You can move it, but this is the way how you can fix this kind of simulation. So as you can see with the context steering module, we are able to fix this kind of situation where you have more than one directional module. And again, this is not just for the agent avoidance and the mesh avoidance, but also is all the directional modules, all the modules that are changing the direction of the agents. Then you can combine them together using this module. Finally, one last thing is that in the context steering, you also have the locomotion section. So you could have also changed here a linear maximum velocity and other parameters here. Also here we have also a max turn angle. So depending on the result that you have coming from the other modules, you still have so the context steering module is gonna find a new direction from the agents, but you can still clamp the variation of the direction, so the angle between the old direction and the new direction with this max turn angle. So even if you set this one to a higher value, you could also you know, change the result of the animation. Okay, so yeah, let's go and have a look how we can create an avoidance and drive that manually. Now let's create a scene where we're gonna make our agents avoid these tubes without using any agent avoidance or mesh avoidance. So here, let me hide the grid just for a second so we can see better. I've created some curves, some outer curves that are gonna drive the direction of the agents. It's important also to know that it's important the order in which the vertices are created for the curve. So if you start creating them from this point to this point, the agents are gonna go in this direction, right? So from this point to this point, while if you create them from here to here, then they will go in this direction. So again, it's quite important how you create these curves. Then we have some curves, 2 curves for each obstacle. So let me create a new agent group in this scene. And on this agent group, we're going to create again a grid layout let's see, a grid layout, a state machine, and add metadata again, and grid layout, let's make maybe 10 by 10. They're gonna go in the other direction, so they're going this way, 200 and 200 for the spacing, and then let's add like a random spacing to 50-50. Great. Cool. So state machine, I'm gonna use the state 4. If we go in the state machine in the Atomos UI, we'll see that the state 4 is actually the locomotion state. It's using the same locomotion that we used in the previous example. So this is just to show you that you can also use a locomotion state within a state machine. Because we're using a locomotion, then of course we need to provide a velocity. So it's gonna be 130, like this. Let me change the draw to skin. So if I press play now, the agents are walking straight and intersecting with the cones that we have here, the tubes. So to make them avoid them, we're gonna use curve fields. So first of all, we need to create the main curve field with the one with the outer curves. So first one, curve field. Let's go in here, then add 2 curves. We're going to select under the object context. We're going to select main curve 1 and main curve 2, like so. Everything else, we're gonna keep it in that way. The simulation is not gonna change much because the curves are basically just saying to the agents, just pretty much do what you were already doing and just follow this direction. So then we can create a new curve field, and on this curve field we're going to add 2 curves again. So the 2 curves are obstacle 1, yeah, and no, sorry, yeah, obstacle 1 and then obstacle 1, 2. So let me check if they're actually correct. 1, 1 and 1, 2. Right. We see that here the agents are already, turning, and this is because we have not set any influence radius for the curves. So we can do that by going on the agent group. Actually, let's go like this. On the agent group, we can say for this curve field, for second curve field, we want to have a max distance of maybe 300 and a drop off of 50. So basically, whenever they're closer than 300 units, they're gonna start following the curves. Otherwise, they will just ignore these curves here. So if I press play now, we see that the agents are kind of following these curves, but they're still intersecting. And this is because the max turn angle here is the same as the curve field here. So basically what I'm trying to say is that the agents, when they go through this behavior module, they will turn by 5 degrees at maximum. And then when they reach this other module, they will turn at 5 degrees maximum. What we want to do here is just to make sure that they are avoiding this tube. We can set the max turn angle to a higher value, so take 10, something like this, and now they should avoid that obstacle. They're intersecting, but we're gonna fix that later. Actually, let me maybe say 400 or something like this, so maybe we have a bit more radius. Yeah, that's cool. Great, so that's done. Then we can create a new curve field. Actually, let's add 2 more. So on this one, we're gonna add the other obstacle. So it's gonna be 2, 1 and 2, 2. Same here. So here we said 450 and max turn angle 10. So 400 the max distance and 50 for the drop off. 10, 450. Again, we're adding 2. So these are the curves of the other obstacle over here. So now we should see the agents, avoiding these cones and pretty much also avoiding each other. Although we see some intersection around here. Actually, let me just make it go a bit slower. So these two guys, for instance, they're intersecting, some other guys are intersecting here, and so on. So we can fix that by moving agents or by using the agent deleter. Then we can check when some agents are intersecting. So like this guy over here, that guy, we can open the selection tool, go in selection mode, select this guy. Then we can go back the layout and move it like so. Then if we press play, the result should be a bit different. And in fact, they're not intersecting that much anymore. So basically, you could do the same for other agents here, or if you can't really fix some of the intersections, you can still filter them, filter the agents. But in this way, as you can see, you have the total control on the simulation. If you're not happy with how the agents are turning around the obstacles, you can always change the max turn angle on the curve fields. So if you think they're turning if the turns that they do are way too sharp, or if you want to even change the way they turn, that's just a matter of adjusting the curves that are that we have in the scene here. And this is all for this video. Thanks for watching.